Okay, page 2. According to the National Constitution Center, 18% of Americans trust organized religion. If an American is randomly selected, what is the probability that he or she trusts organized religion? Well, that was given. 0.18, right? That percentage is also probability. If an American is randomly selected, what is the probability he or she does not trust? That's the complement, so we do 1 minus, that's everybody else. That's the other 82% of the people. Random sample of 3 Americans, all 3 indicate they trust organized religion. Is this result surprising? Well, the probability that they say that they do would be 0.18. That's the probability that the first person does trust, and then 0.18 and 0.18, right? So it's going to be 0.18 to the third, and then so I'm just calculating the probability now, and then we'll decide if we on the question. 0.0058. So I think it's pretty clear that that would be surprising. 0.0058. So again, I think on the test I'll change it to 3 or even 4 decimal places, especially for these small probabilities. So let's say I make that change to 4. And don't worry, I'll be clear and I'll be lenient on rounding, so don't stress about rounding. Okay, so that's the probability that all 3 of them say yes if I chose 3. So I can answer the question, I'm pretty sure, yes, it's surprising because such low probability. Probability less than 1% chance, right? If 3 Americans were asked, what is the probability that at least 1 does not trust organized religion? At least 1. So the probability is going to be equal to probability at least 1 does not equals 1 minus the probability that all 3 do trust, right? The complement of that. At least 1 does not trust is 1 minus the probability that they all do trust, right? So that's 1 minus, and we just calculated that, right? That they all do trust. So that's just going to be 1 minus 0.0058 is equal to 0.9942. Okay, so again, it's good to think about, does that answer make sense? The intuition isn't easy, right? You would think that that it should be a high probability. Before I did that, we should have guessed. It should have been high, right? Only 18% say they don't trust. So if you're going to pick 3, there's a pretty good chance at least one of them does not trust because 82% don't trust. Right? So it should be pretty high, so I'm pretty happy about the answer. Okay, moving on. Probability distribution, chapter 6. We are now into chapter 6. So here's a probability distribution. If I want to verify that, I got to add all these guys up. So here's a good answer. 0.06 plus 0.58 plus 0.22 plus 0.10 plus 0.03 plus 0.01. If you add those up, you should get 1. Represents the number of movies streamed per week in a household for Netflix users. This should be probably 5. Well, I want to make a change. Sorry if this confused you. This should probably be 5 or more. I think we talked about that once in class. Just so there's no confusion, if I don't put the 5 or more in there, that means that no one is watching 6 movies a week, which probably isn't really realistic, right? There's got to be at least some people, especially right now, binging some movies. So that should be in there. I hope that didn't confuse you. Let's see where that issue might come up. If one household is chosen, what's the probability that the household views at least 1 movie per month? So that would be all these guys added together, right? At least 1 is 1 or 2 or 3. If you wanted to write it as a probability, which I don't need you to do this, I just need the answer. ... Well, plus probability 4, 5, or more, right? Which is equal to, is an easy way to do this one, 1 minus the probability that it's 0, right? And mean, if these all add up to 1, then the answer's got to be 0.94, right? Which is 1 minus that guy. So either way, you should get 0.94 for that. And at most 3 movies. So you got to be careful with the at most question. That means, what's at most 3 mean? That means 3 or 2 or 1 or 0. So that's going to be these guys, right? At most 3 would be the sum of those 4 numbers. Or, again, you could do 1 minus 0.03 minus 0.01. Use the complement to save yourself a little bit of trouble. I get 0.96. Okay. What does it mean for this distribution? Interpret that. Okay, so mean. So you get a formula sheet, and you get something that looks like this. It would be x times p of x. Right? And that's all it says, and it might say equals mu equals expected value of x. So you have to interpret that, but just, I mean, don't worry too much about the formula, just do the math. So the math goes like this. It's going to be, for this example, 0 times 0.06 plus 1 times 0.58 plus 2 times 0.22 plus 3 times 0.10 plus 4 times 0.03 plus 4 times 0.03 plus 5 times 0.01. And here's where that issue comes up that I talked about, the 5 or more. So it is an issue because we don't really know 5 or more, but it's such a small probability. This is, even though this could be a 6 or 7, this number is so small that it really won't affect our mean. So we have a pretty good answer either way. It's not a huge deal. What do you get when you do that? Let's see. I'll use my calculator. 0.58 plus 0.44. Oh, by the way, if you look at that, you should be able to come up with a decent guess. Let's see. A lot of them are just watching 1, right? So I'm gonna. It should be in here somewhere. Between 1 and 2 is my guess, right? Because you have 58% just doing 1, 22% watching 2, and then it trickles off pretty quickly. So my guess is going to be between 1 and 2. Let's see what we get here. 0.58 plus 0.44 plus 0.30 plus 4 times 0.03 plus 5 times 0.01. If I did that right, I got 1.49. And I wanted you to give me some units there. 1.49 what? Remember, that's not a probability. 1.49 movies. Number of movies watched per week. Okay. Let's just keep going. This video will be a little long, but that's okay. Term life insurance policy pay. Okay, so here is your life insurance policy question, which is similar to like the roulette question. We're doing expected value. Term life policy will pay a beneficiary a certain sum of money. Suppose sells $250,000. Okay. Here's your probability that they survive to be the expected value policy to the insurance company. So there's to the insurance company. So I usually do my little chart. The book will do this a little differently. This is what can happen. This is the value, which should be in money, and this is the probability that occurs. You could live, I think we did this one in class, or you could die. Probability that you, or to the insurance company, if you live, they get to keep your money, right? So how much is here's the what it costs. So they just get to keep your $530. And the probability that they get to keep that is 0.99791. If they die, the probability someone dies, a 49-year-old female dies, is 1 minus 0.99791, which is 0.00209. Right? And how much do they make? Well, you got to be careful with this one. They don't take $250,000. They take $250,000. I'm sorry, they pay out. If you die, they pay out $250,000, but they get to keep your $530, right? So that means that they only made 250,000 minus 530,